Okay, this is Mrs. Ward. I'm going to go over the 5-5 homework, which is half angles and double angles. So I don't know why I put this here. This is not the right formula sheet. So let's go. You should have your formula sheets next to you. So you have this one, this angle here. The first thing I have to do is find the missing side, correct? So to find the missing side, I'm going to do 5 squared plus 12 squared is equal to, I'll call it x squared for lack of anything else. This ends up being 169 is equal to x squared. So take the square root, and you get 13 for x. Technically plus or minus, but since it looks like it's the hypotenuse, I'm going to make it positive. And when I find the sine of theta is going to be the opposite over the hypotenuse. The cosine of theta is going to be the adjacent over the hypotenuse. Now when I'm doing these double angles, I'm looking at my formula sheet, and for sine I only have one that I can use. And the one for sine 2 theta is that 2 times sine theta cosine theta. So we already found sine theta and cosine theta, right? So we're going to take 2 times 5/13 times 12/13. And when I do all that, this 2 is in the numerator, so I'm going to get 120 over 169. And that's my sine of 2 theta. Everyone good with that one? All right, when I go to do the next one, I have 3 choices that I can use. Since I already have both sine and cosine, I'm just going to stick with the one that has cosine squared minus sine squared. So cosine 2 theta is equal to, I forget it now, is it cosine first? Yes, cosine squared minus sine squared. So I'm going to take my cosine, which is 12/13, square that, minus my sine, which is 5/13, square that. So this is going to be 144 over 169 minus 25 over 169. And when I subtract, I get 79 over 169. Okay, I got help now. Thanks, guys. So this is 119 over 169. Everyone good? Okay, moving on to the next one. So now it says use a graphing utility to approximate the solutions of the equation in the interval from 0 to 2 pi. If possible, find the exact solution. So you are, which ones are you doing? All of these?
3, 5, 7.
Okay, and 9. So if I have sine 2x, remember there's only one way that I can write sine 2x. So that's going to be 2 sine x cosine x minus sine x is equal to 0. So all I did is in place of this sine 2x, I wrote what sine 2x is equal to. Now, just remembering what we did in the last chapter, here I have a sine x, here I have a sine x, so I'm going to factor that out. So I'm going to have sine x times what's left here is 2 cosine x, and then since I factored that sine x out, I'm going to have a 1 is equal to 0. I have 2 things multiplied is equal to 0, so I'm going to use the 0 product property. So I'm going to say sine of x is equal to 0, and 2 cosine x minus 1 is equal to 0. When is my sine equal to 0? And you tell me 0, pi, and technically 2 pi, but that's not part of that interval. And then 2 cosine x, add 1 to both sides is equal to 1. Divide both sides by 2, and I get 1/2. Then I ask myself, when is the cosine equal to 1/2? And that's at pi over 3 and 5 pi over 3. It just wants that interval from 0 to 2 pi, so you don't have to write the multiples of 2 pi. So these are going to be my solution. I feel like I'm going really fast. Should I slow down?
Yes.
Okay, for this one, I'm looking at it, and I cannot set, there's nothing that I can factor out. I can't factor anything out. I can't set it equal to 0 because I have that 1 over there. So what I decided to do was work it backwards. So I'm going to rewrite this 4 times the sine x cosine x as 2 times 2 sine x cosine x is equal to 1. Then I'm going to use the double angle identity to rewrite this. And so that'll be sine 2x. And I'm going to have 2 times that is equal to 1. Everyone good? I made this, I used my identity to rewrite this as this. Now what I'm going to do is divide both sides by 2. And when I divide both sides by 2, I'm just dividing the coefficient. I cannot divide that 2x out of there. Does that make sense? Because of order of operations. So now I have sine of 2x is equal to 1/2. So now I'm going to just think of this. If I had, I'm just going to think of sine of, like, let's pick a different letter. Let's say theta. If I said the sine of theta was equal to 1/2, you would tell me theta is equal to what? When is the sine equal to 1/2? Pi over 6 and 5 pi over 6, right? So this is the same work, but instead of having theta here, I had 2x. So 2x is going to equal pi over 6, and 2x is going to equal 5 pi over 6. So now to find just 1x, I'm going to multiply both sides by the reciprocal, or divide by 2. I would prefer to multiply by 1/2 than divide by 2. So here I'm going to get x is equal to pi over 12, and here I'm going to get x is equal to 5 pi over 12. Okay, now I'm going to do number 7. Number 7, I have 3 formulas for cosine 2x. Since I have this cosine here, I'm going to pick the formula that only has the cosine x. So I am going to rewrite cosine 2x. I'm going to rewrite this cosine 2x as 2 cosine squared x minus 1, and then I'm going to subtract that cosine x is equal to 0. So what I did is I rewrote this using the formula. Now I'm going to product sum. So I'm going to rewrite it in descending order. So I'm going to do 2 cosine squared x minus cosine x minus 1 is equal to 0. So my product is -2. My sum is -1. Do you feel like we do the same product sum all the time? So I'm going to use -2 and 1. So -2 cosine x plus cosine x minus 1 is equal to 0. From the first 2 terms, I'm going to factor out a 2 cosine x. And I'll be left with cosine x minus 1. And then here, there's nothing I can factor out, so I'm just going to write a 1. So I'm going to have 2 cosine x plus 1 cosine x minus 1. Set that equal to 0. Can I go fast now? 2 cosine x plus 1 is equal to 0. Cosine of x minus 1 is equal to 0. Solve those separately. Here I'm going to subtract 1 from both sides. Then I'm going to divide by 2. So when is the cosine of x equal to -1/2? And you say 2 pi over 3 and 4 pi over 3. Over here, the cosine of x, add 1 to both sides, is equal to 1. When is the cosine x equal to 1? And that's 0 and 2 pi, but I'm just going to write 0. And these are my 3 solutions. So what they do is they bring this over. So they have sine 4x is plus 2 sine 2x is equal to 0. So they had that. And then what they did,
Why don't you factor something out?
well, what they did, I don't know where they could possibly get this.
Don't need a photo math
They made this 2 sine 2x cosine 2x plus 2 sine 2x is equal to 0. And then they factored out a sine 2x. So I'm factoring out a sine 2x. And I'm going to be left with 2 cosine 2x plus 1 is equal to 0. So here I have sine 2x is equal to 0. So this is back where I have to go back and think about theta instead. So if I asked you, when is the sine equal to 0, you would tell me at 0 and pi and 2 pi, right? Yes? And now, so in place, that was my theta, so now I'm going to say 2x is equal to 0, 2x is equal to pi, 2x is equal to 2 pi. So that'll give me answers of 0, pi over 2, and pi. Yes, ma'am. I'm going to subtract 2, so 2 cosine 2x is equal to negative 2. Divide both sides by 2, negative 1. So then I ask myself, when is the cosine equal to 1? So when is the cosine equal to negative 1? And that happens at pi. So then I'm going to say 2x is equal to pi, so x is equal to pi over 2, which I already had that answer from over here. You will never get one that hard, ever. Moving on. Okay, these ones, find the exact values of sine 2 theta, cosine 2 theta, and we're not doing tangents. So you're crossing off tangent using the double angle formulas. So if I have a triangle and I know that my sine is 3/5, what does this side have to be? 4. So the sine of u is equal to 3/5. The cosine of u is equal to 4/5. So this is just like the one that we started off at the beginning of class. If I want the sine of 2u, I'm going to take 2 times the sine of u, cosine of u. So I'm going to write that 2 over 1, and then 3/5 times 4/5. And I'm going to get 24 25ths. And then to do the cosine of 2u, I'm going to do the cosine squared minus sine squared. So cosine 2u is equal to cosine squared u minus sine squared u. So the cosine is 4/5, so 4/5 squared minus 3/5 squared. So 16 25ths minus 9 25ths, and I'm going to get 7 25ths. Now I'm going to do 14. This one, I don't know if I pointed it out. It told me it was in the first quadrant, right? So that's why I made both my sine and my cosine positive. 14, they're telling me that it's between pi over 2 and pi. So they're telling me it's in what quadrant? Second quadrant. So this is telling me that it's in the second quadrant, which means my cosine will be negative, my sine will be positive. So I'm going to draw that triangle in the second quadrant with negative 2/7. So second quadrant, negative 2/7. Now I have to find this side here, so I'm going to take negative 2 squared plus x squared is equal to 7 squared. So x squared is equal to 44. Take the square root, and that'll end up being 2 times the square root of 11. Oh, 45. So that's 3 times the square root of 5. And that's positive because it's in the second quadrant. So now I'm just going to write that the sine of u is equal to 3 times the square root of 5 over 7. The cosine of u is equal to negative 2/7. Now I want to find the sine of 2u. So I'm going to do 2 times the sine. Can I just skip to putting the numbers in? Times the cosine. And when I do that, that's going to be negative 12 times the square root of 5 over 49. Two times 3 is 6 times negative 2 is 12. Then to do the cosine of 2u, I'm going to do the cosine squared, so negative 2/7 squared minus the sine squared, so that's 3 times the square root of 5 over 7 squared. This is 4 over 49. Remember that negative 2 becomes positive. This, 3 times the square root of 45, or 3 times the square of 9 squared is that 45, right? So that's going to be 45 over 49. And when I subtract, I get a negative 41 over 49. So these ones I'm just trying to rewrite. I have my formula sheet. I see sine x times cosine x. And the only one that has sine x, cosine x is that, sine 2u is equal to 2 sine x cosine x. So I'm looking at that formula. I have that sine x cosine x, but instead of having this 8, I might think of that as 4 times 2 sine x cosine x. So this is going to be sine 2u, or 2x I should say, because they had an x, so 2x. And then I have that 4 out in front. So this would be my final answer for number 19. For number 20, I see 4 sine x cosine x plus 1. Again, the only thing that has a sine x times a cosine x is this double angle here. So I'm going to rewrite that 4 as 2 times 2 sine x cosine x. And then I have that plus 1 hanging out over there, yes. This is sine 2x. So here's that 2 and here's that plus 1. And that's it. That's all I can do with it. The next one, I have 6 minus 12 sine x sine squared x. So I'm looking at my cosine double angles. Everyone's looking at your cosine double angles. The one that has, I have 1, so I have cosine 2u. The one that has sine is 1 minus 2 sine squared u. So here, if I want a 1 here, I'm going to have to factor out a 6. So I'm going to say 6 times 1 minus 2 sine squared x. This is cosine 2x. And I'm just going to put the 6 in front and make it 6 cosine 2x. Okay, this one is, I know I'm using my half angles because I have cosine of theta over 2. So I'm going to complete the square, I'm doing Pythagorean theorem, sorry, to find that missing side. So if I do 15 squared plus 8 squared is equal to my hypotenuse squared, I believe that ends up being 17. So this is 17. So if you're looking at the half angle formulas, the only thing you need is you need the cosine. You need the cosine of u. You do not need to know the sine. So to do the cosine half angle formula, that's going to be cosine of theta over 2 is equal to plus or minus the square root, and then it's 1 plus the cosine of theta over 2. That's the formula. So I'm going to do plus or minus the square root of 1 plus the cosine in this case is going to be 15/17. Is everyone good with that? All over 2. Now, your calculator is not going to have to help you because you'll get a decimal and you're not allowed to give me a decimal. So what I do is I look at this and I want to rewrite this. I want to first simplify this numerator. So this 1 I'm going to rewrite as 17 over 17 so I have a common denominator. When I do that, I'm going to take 17 plus 15 and get 32 over 17. And I'm dividing that by 1/2. I'm sorry, I'm dividing that by 2, which means I'm going to multiply by what? 1/2. So I'm going to have 32 over 17 times 1/2. I can simplify these, yes, and get 16 over 17. When I simplify the 2 and the 32, so the square root of 16, square root of 17. So I'm going to end up with 4 over the square root of 17. Rationalize. And my final answer is going to be 4 times the square root of 17 over 17. That plus or minus out front just matters whether you're in the first quadrant or second quadrant. But if this angle is drawn in the first quadrant, if I take half of any angle in the first quadrant, it's always still going to be in the first quadrant. Does that make sense? Okay, that was the cosine of theta over 2. Now to do the sine of theta over 2, it's basically the same formula. The only difference is instead of doing 1 plus, you're doing 1 minus the cosine of theta over 2. So that's going to be 1 minus 15/17 over 2. So this 17, this one I'm going to rewrite as 17 over 17. So I have 17 minus 15, which is 2 over 17, all divided by 2. So 2 over 17 times the reciprocal 1/2. These will simplify, so I end up with 1/17 square root. So 1 over the square root of 17, rationalize, square root of 17 over 17. 2, I want to find the exact value of 15 degrees. So it tells me to use the half angle. So the first thing I'm going to do is I'm going to look at this angle and I'm going to double it. What's 15 times 2? 30. So what I'm thinking of is I want to do the cosine of 30 degrees over 2. So I'm using that half angle formula. So when I do this, this will be, well, 15 degrees, is it going to be positive or negative, the cosine? Positive, because it's in the first quadrant. So when I do this, I'm going to do the square root of 1 plus the cosine of 30 degrees all over 2. And you're telling me the cosine of 30 degrees is the square root of 3 over 2. And this is all over 2. Now I guess the calculator trick doesn't help you here. This 1 I'm going to rewrite as 2 over 2. So I'm going to have the square root of 2 plus the square root of 3 over 2. Can I multiply by 1/2 while I'm here?
Yes.
Beautiful. So I'm going to have the square root of 2 plus the square root of 3 all over the square root of 4, because that 2 times 2 is 4. So the square root of 4 is 2. So I'm going to have 2 plus the square root of 3 all over 2. And that's it. That's my answer. Not bad. So now when I do the sine of 30 degrees over 2, that's going to be a minus sign. So I'm going to do the square root of 1 minus the cosine of 30 degrees over 2. So when I do that, I'm going to have 1 minus the square root of 3 over 2, all over 2. So it's going to be the same answer you just got, except for it's going to have a minus sign. So I'm going to have the square root of 2 minus the square root of 3 over 2 times 1/2. So 2 minus the square root of 3 over the square root of 4. Again, 15 degrees is in the first quadrant. It's going to be positive. So when I go to do the next one, which is 165, first thing I'm going to do if I'm using the half angles, I'm going to take 165 and do what with that? Double it. So what's 2 times 165? 330. Now also, if I have 165 degrees, what quadrant is 165 degrees in? It's in the second quadrant, right? Because it's between 90 and 180, which tells me that my cosine is going to be negative, my sine is going to be positive. I'm just going to remember that. So here, when I go to do the cosine, I know, so I'm going to do the cosine of 330 degrees over 2. That's that 165. I'm going to make it negative because I know that my cosine is negative in the second quadrant. So I'm going to have 1 plus the cosine of 330 degrees over 2. Cosine of 330 degrees is positive square root of 3 over 2. Yeah, over 2. So that's going to be the same work that's up here as 30 degrees, yes. The only difference is this one's going to be negative. So I'll do all the work again. So I'm skipping steps though. So that's going to be a negative square root of 2 plus the square root of 3 over 2 times 1/2. So negative square root of 2 plus the square root of 3, and that's all over 2. Sine of 330 degrees over 2. It's going to be positive because I'm in the second quadrant. That 165 is in the second quadrant, so my sine is positive. 30 degrees over 2.